Okay, sure, I will.
I have a question. Can we just do the box instead of writing all that? Just use the box and drop down one at a time. Like what on the model thing?
After the tricycle, yes, you can bike on it, right? But then I'm telling you that yes, eventually you are going to, be free to do the part that you think that's the best for you. I have to introduce the whole process to help everyone in different level. So if you don't need some of the parts, just be patient. Okay? So let me tell you, I'm going to do one more time. So you're going to see the whole process one more time and see whether you can do the same thing. Okay, so I'm going to do it one more time. Just be patient. Okay. All right, this is the problem, number 33. It's still the same problem, so I just want you to be patient. So can I have some of you, volunteer to tell me what to write down for your understanding? Yes. No, not for this moment. I'm going to do one more time, and I want you to see how much time you need to do this whole process. Okay? Many students do not want to do this process. They feel like it's, taking time. But I have to share with you, it's worth your time to break things down so that you're more focused on the understanding of a smaller chunk, and you can organize them into a more organized model than that you kind of like confused by a very, very long paragraph. Okay? So let's see how much time we need for doing this. Okay? This is the same problem. Okay? You are doing the same problem. So I'm going to have you answer me. Okay. Hey, Jun. Would you please tell us what do you know first? Okay. The total distance is 20 miles, right? Commute. Sorry? I'm writing it one more time. Yes. Let's choose the other one. I would like to. Okay. I'd like to do a different one, but let me tell you, I have this in mind for one purpose. Some people, and this happened in the past, I have tested you the same problem several times already. And what is the result? Yeah, or some people still bomb. And I asked that student, and that student just say, I understand the first time, but then the second time I forgot. Why you forget? Can anybody share with me? Why you forget? Short-term memory.
We have a lot of information coming through our ears.
I'm going to let this problem go since some of you have that request. Is that okay? I will let you review this at your own time. Okay. And you have to time it. I was about to time, see how much time would it be for the second time doing? Yes. Next test will be all word problems. With how many? It probably will have 8. Well, maybe, some are. Then I have to help you, and I have to help you so that you can do it in a timely way. Maybe not 20. But maybe a bit like around 10 minutes, okay? You're going to get there, okay? You're going to get there. We'll see. That's why that I was about to time for the second time doing. You would know that, what would it take? It's not 20 minutes. Zaya? Yeah. Oh, to solve it, it's even less. Okay, come back to this one. All right. So you know what? I'm going to just use this to go over it without writing. Okay. So first of all, Heijun, the first item that you got was the distance was 20 miles in total, right? And then the second is what? The ongoing trip is what? Easier than the returning. The third, it takes the same time traveling to work and traveling 16 miles back home. Okay? It's very straightforward, right? If you want, you probably would draw the diagram here. Oh, going is 20 miles, but then coming back is 16 miles. And then the average speed back home is 7 miles, what? Per hour slower than the average speed going to work. Question is, what is the average speed going to work? By breaking it down, it's helping us to sketch the diagram. Okay, oh, when I go to work, it's 20 miles. Okay, and then I am going to take the same time driving to work, and then coming back home, I can only drive 16 miles. It would take the same time. So I know when I go to work, easier, it's faster, but then coming back home, it's slower. Well, this is about distance, speed and time. So rate times time equal to distance. So that is a model in my mind. And I'm going to put all the information that I have learned into an organized model. Either way, they all follow rate times time equal to distance. So if I set the thing that I want to find, what do I want to find? Oh, I want to find the average speed going to work. Okay. The things I want to find is here. I don't know, so I make it S. Okay? Now, the distance going to school, the work is 20 miles. Coming back home, 16 miles. And I know the average speed back home is 7 miles slower per hour than the average speed going to work. Going to work is S. Then coming back will be what? S minus 7, right? Does it make sense? This is the hard part. All right, once you know the rate and the distance, you will know the time. Zaya, yes? So how do you find the time? The distance divided by the speed, right? For 20 miles, the speed is S. So 20 divided by S is the time. For 16 miles back home, your speed is S minus 7. So 16 divided by 7 minus 7 is the time coming back home. Only for 16 miles. And they takes the same time. Aha. So that is the model. What equal to what? Time going to work is the time back home for 16 miles. Does it make sense? Yes. Okay. Now, I say, when you get up here, you get 80% of the credit of the whole problem, or 70% of the credit. Okay, this is how instructors are going to use as rubric. How do we solve this? This is straightforward. This is a proportion, right? How do you solve this? Use common denominators, multiply both sides, right? Use common denominator, because for the general rational equations, you would just find common denominators. Okay, and you found out this is just one term here, one term there. One fraction here, one fraction there. It's a proportion. So if you multiply the LCD, you will just get the cross product equal. Does it make sense? You are going to multiply S times S minus 7 on both sides, right? Multiplying S and S minus 7, S would be divided out, so it's just 20 times S minus 7. And the other side, just 16 times S. Does it make sense to you? I don't need to explain more. So you know this is a proportion, so cross product will be equal. 20 times S minus 7 equal to 16 times S. Super easy. Everybody can solve this one. It's a linear equation, right? So that's why most of the teacher will stop here, because the rest should be students' job. Everyone only need the explanation up to this model setting. The rest, it should not be, should not take too much time, unless you are not very good in algebra. Does it make sense? Okay, so we can still finish this. This 20s minus 140 equal to 16s. So you get 4s equal to 140. So s equals to what? 35. So 35 is the speed going to work. And that's what they want us to answer. So you just need to answer in complete sentence. The speed going to work is 35 miles per hour. Okay? All right. Now let's do the next one. Can I have you all do number 35? Now this time, do the same thing. Except you don't need to copy down the problem. You can just write your understanding in your own words, but numerate them. 1, 2, 3, 35. Everybody has to rewrite. I would give you about 5 minutes to rewrite it. Okay? You don't need to copy down the problem now, but you need to rewrite it. Fine. Okay, Hannah can travel 152 feet walking on the walkway. Okay? In the same time, now you know it's very important to see this in the same time, right? In the same time, it takes her to travel 72 feet. Without the aid of walkway. Does it make sense? Yes. All right. What do we want to find? How fast does Hannah walk? Right? Okay. So if you want to sketch it, you may. Okay? 152 feet, if that is there's a walkway, and so means what? By using that walkway, the speed will be faster. How much faster? 2 feet per second faster. Okay. If she doesn't use that walkway, then she can only travel 72 feet. So you are asking her speed without the walkway. So what are you going to do? You are going to oh, okay. You would like to organize using a table. Fine. Okay. So there are how many scenarios? One is with the pathway. The other one is without the pathway. Is that right? Yes. And either one is rate times time equal to distance. What is the distance with the pathway? 152. What is the distance that she traveled
72.
In the same time? Without pathway, 72. Okay. So what is the speed? We want to find the speed that Hannah walks without the pathway. X. Okay, now you want to use X. Then if she has the aid from the pathway, well, the pathway travels at 2 feet per second, then her speed will be X plus 2. Is this hard for you?
No.
Great job. Now, what is the time? What is the time? It's distance over the rate. 72 over the rate. Yeah? And it says in the same time, so means the time will be equal, right? So now you know, if you would like to find out what is equal, you say time with pathway for 152 feet equals to the time without pathway for 72 feet will be equal. Okay? That is 152 over x plus 2 equal to 72 over x. I do not need to solve this. You know how to solve it, right? This is the most important part, modeling. Okay, does it make sense? Okay, now let's do the next. Can I have you do number 31? You see number 31? Emptying a pool. Okay, number 31. A swimming pool can be emptied in 6 hours using a 10 horsepower pump along with a 6 horsepower pump. The 6 horsepower pump requires 5 hours more than the 10 horsepower pump to pump the pool when working by itself. How long would it take to empty the pool using just the 10 horsepower pump? It's like a tongue twister, huh? Okay. Please. I would like you to do the same thing very quickly. Maybe you only need to spend 2 minutes now. Rewrite this problem. Write down those important information that helps you to solve this problem. Okay? Okay, now I want you to read out loud the problem to each other. Just the problem. Just the problem. Are you listening? I know you may not need the rewrite, but still, I want you to practice that, both of you. You know, draw down what is being said in that problem. You know, in your own words. Okay. Yeah. I know some of you may feel more comfortable using Japanese to rewrite it. Yeah, you may, or you use Russian. Well, but then at the end, you have to translate back to English so people can understand what what did you write. Yes, you can rewrite it in Spanish. It's your understanding, right? But then you have to translate back so instructor can understand. Anyone would like to share your rewrite? Sorry? Spanish. You have the Spanish rewrite?
No. I don't even understand it in English. How am I supposed to understand it in Spanish?
We will do together. Okay, can anyone share with me what did you rewrite for this problem? Lena? What is the first thing you know? Sorry? Okay. So it says the swimming pool can be emptied in 6 hours by both pumps, right? All right, what is the second thing that I should say? Okay, the 6 hours pump, the 6 horsepower pump takes how many more? 5 hours more than the 10 horsepower pump. Okay? To empty the pool by itself. Aha. Okay. So what does it mean here? Okay? Means if you know how many hours that the 10 horsepower needs, then the 6 horsepower pump would need that many hours plus 5 hours. Does it make sense? Okay. All right. What else we know? That's all we know. Am I correct? Okay. Question. What do we want to find? How long does it take for the 10 horsepower pump to empty the pool by itself, right? Wow. Okay. Now, I think many of you got similar understanding as what I just written here. What should we do? Can I draw a diagram, or can I organize it using some kind of table? You like table? Fine. Somebody say, I love draw. So yeah, you may draw. Okay, the same size of pool. Okay, I don't know how many hours that I need, but obviously I'm going to drain it out. Okay, and to drain it out, I have a big pump, and the other one is a smaller pump. The big pump, I don't know, it's a 10 horsepower pump, so it takes shorter time. But then the smaller pump will take 5 more hours, right? But when they work together, it takes how many hours? 6 hours, okay? And you don't know how many hours would it take for the larger pump or 10 horsepower pump. So that is something I want to find. So if that is something I want to find, probably you would like to set it as a variable, right? What is the name you would like to set? Okay, let x be the time for the 10 horsepower pump to empty the pool by itself. Okay? Well, if that is the time, let's say x hours, then how many hours for the smaller pump or the 6 horsepower pump? as x plus 5. Okay. If you can pump out in x hours, every hour you can pump out how much? So this is a task. For this task, you would like to pump out the pool, right? This is the pool. This is the pool. Okay, so in 1 hour, how much could be pumped out? How much? How much? X hours, you can pump out all. In 1 hour, you need to pick up the copy. You need to pick up the copy. Okay, right now. How many? What is the portion? Say if you can pump out the water in 3 hours, then every hour you can pump out how much? 1/3, right? If you can pump out in 10 hours, completely pump it out, then in 1 hour you can pump out how much of the whole pool? 1/10. So now you can pump out X hours. You can empty this in X hours. Then every hour, this pump can pump out how much of the pool? 1 over X. Thank you. This is the hard part for most of the students. Okay? If it needs X hours to pump it out, okay, then its rate of working equals 1 over X per hour. Okay? Great job. So if X hours is the time for the big pump, then the smaller pump needs X plus 5 hours. Then we can know, oh, for this smaller pump, every 1 hour can pump how much? 1 over X plus 5. So you say, if X is the time for the big pump, then X plus 5 is the time for the 6 horsepower pump to do the same pumping, right? Then, what is its rate of working? Its rate of working is what? 1 over what? X plus 5 every hour. Does it make sense to you guys? This is the key part. Okay, by knowing the time that you need to complete the whole job, you would know the speed per hour, how much can be done. Does it make sense? It's 1 over. Why 1 over? Anybody can tell me why 1 over? We are considering the whole job is one job. Does it make sense? Okay? All right? The whole job being divided into X hours. Okay. All right. With this, we say, hey, maybe I can organize this better using a table. Okay? So using a table, we say this is a 10 horsepower pump. This is 6 horsepower pump. Okay? For 10 horsepower pump, time alone is the time that for itself to finish the job. And we say, what? X hours, right? X hours. If it takes X hours for this big pump, then for the smaller pump, it will be what? X plus 5 hours, right? We are all talking about hours. All right. And then we say, by knowing the time, we would know the rate of working. So the rate of working for the large pipe is 1 over X. For the smaller pipe is 1 over X plus 5. Does it make sense? Okay. Now, what else we know? What else we know? Okay? We know we haven't done. This has been done, right? We already know that it takes 5 hours longer for the smaller pump to empty the pool, but we haven't used this important information. What does it say? By both pumps, the swimming pool can be empty in how long? 6 hours. Oh, so if I work 6 hours, okay, if I work 6 hours, then how much work? How much work can be done by the larger pump? It will be the rate times the time. So 1 over x times the time. How much work will be done by the smaller pump? It will be rate times the time. Okay? So for 6 hours, they finished the whole job. Means what? You add up the work they did. It will be a complete job. Does it make sense? Okay? The total work, it will be whole job. Okay? It will be a whole job. They finish pumping in 6 hours. So what do you say? You say work done by 10 horsepower pump plus the work done by 6 horsepower pump is one whole job, because I just want to empty what? One pool. Let me ask you, how about if I say it takes them 6 hours to pump half of the pool? Then what would you say? You say in 6 hours, okay, work done by this in 6 hours. They are all in 6 hours, right? Okay? It's only pump out 1/2 of the pool. Then you would say, okay, work done by the big pump in 6 hours plus the work done by the smaller pump in 6 hours is just half of the job. Then you need to write down half. Does it make sense? Okay? But right now we say in 6 hours they can pump out the whole pool, right? That is a whole job. Okay? So the work done for the large pump is this, 6 over x. The work done by the smaller pump is that, is 6 over x plus 5 equals to 1. Okay? Can you solve this now? Yes, right? What is the LCD? X times x plus 5. So I would have x times x plus 5, multiply every term. X times x plus 5, multiply every term. X times x plus 5. Then I can have 6 times x plus 5 plus 6x equal to x squared plus 5x. This is a quadratic equation. Am I correct? And you can solve it when you get home. All right. Thank you so much. I think you learned a lot. Let me tell you, you have homework. Okay? The homework will be all every odd on this textbook. Okay, you have already done some, so you can just, redo them.
That's 5.6.
Yeah.
Can you post on Canvas?
Yeah, I can. Yeah, and then you will have a little bit more than this. I will post on Canvas. I will post on Canvas, yes. All right, this is a packet. You know what? I think for today, I will just this packet and those few problems on, 5.6, right? Okay, so 5.6, every all in this packet for today. The whole packet? The whole packet. Thank you so much.